Let's take a look at some examples from 8.6. The first one I'm going to do is find the component vector mn, where m is the point 2, -2, and n is the point -3, 4. So we want to find what are the components that make up this vector. How far does it go left or right? How far does it go up and down? So remember, we do the x final minus x initial to get the x component, and then the y final minus the y initial to get the y component. So we're going to n, so do -3 minus 2, and then we do the same thing with the y's. We're going to n, so do 4 minus -2, so this y minus this y, and that'll be our components. So -3 minus 2 is -5. 4 minus a negative will make that a plus 2, which will make that 6. So to go from m to n, we go to the left 5, and we go up 6. So that's the component form of that particular vector. All right, let's add two vectors together. Let's suppose that vector u is 2, -9, and vector v is -3, 6. If we want the resultant vector, we just add the x components. So 2 plus -3. That'll give us the result in the x direction. Then we add the y components. -9 plus 6. So that resultant will be -1, 3. Oops, -3. So, for example, let's look at what a graph of this would look like, just to verify that what's going on. So, vector u is 2, -9. So let's just start it at the origin for convenience. So if we start at the origin, we go over 2, down 9. So there's vector u. And if we add vector v, then at the end of u, then we're going to do v, which is -3, 6. So from where this one ended, we go to the left 3 and then 6 in the positive direction. So 1, 2, 3, 4, 5, 6. So our resultant is from where the first vector started to where the second vector ended. So we have a net result of going to the left 1 and down 3. You could think about it as a path. If we go the path u first, and then from the end of there go the path v, our result is equivalent to going where we started to where we ended there. So that would be our resultant, u plus v. Now addition is commutative, so if we would have done in other order, if we would have done v and then u, we would have ended up with the same vector. Okay, so let's do this one. It wants us to calculate 2u plus 4v, where u is 3, -1, and v is -2, 5. So if you watch the video from this section, 2u, 2 is a scalar multiple. So we're multiplying the number 2 times the whole vector u. So we're doing 2 times 3, -1. And then we're doing the same thing with v. We're doing 4 times the vector v. So the way this works is 2 gets multiplied times each component. Essentially, we're doing that vector plus itself, or we're drawing that vector twice, which means we're going to go in the x direction 6, and in the y direction we're going to go down 2. If we draw this vector 4 times, then we're going to go to the left 2 4 different times. So 4 negative 2's will be negative 8. And we're going to go up 5 4 different times. So 4 5's would be 20 in the y direction. So this is what 2u's makes. This is going v 4 times. So we want to add those together. So we add the x's together, 6 plus negative 8. We add the y's together, negative 2 plus 20. So that's 2u plus 4v. Now let's do something else with it. Let's do this. And remember, while that looks like absolute value, essentially what that means is to find the length of this vector. So whatever we get for 2u plus 4v, find the length of it. So what is the length of the vector negative 2, 18? So remember, it's basically the distance formula, or the Pythagorean theorem. It's the x part squared plus the y part squared. That gives us the hypotenuse squared. So to get the hypotenuse, take the square root of it. So negative 2 times negative 2 is 4. 18 times 18 is 324. We need the square root of that. So the square root of 326. And then you could simplify that square root depending on if it wants it as a radical or if it wants it as a decimal. All right, let's see what else. Let's do a similar problem to that. Let's take these same values. Let me copy this. All right. Instead of finding the magnitude of 2u plus 4v, let's find the magnitude of 2u plus the magnitude of 4v. So let's find 2u. So 2u's would be 2 times 3 and 2 times negative 1. So that's multiplying the x and the y components by 2. And then to get 4v, multiply the x and the y components by 4. So that'll give us negative 8, 20. And this wants us to get the magnitude of this one, the magnitude of that one, and add them together. So the magnitude of this one is the square root of 6 squared plus negative 2 squared. The magnitude of this one is the square root of negative 8 squared plus 20 squared. So we get 36 plus 4, so that's the square root of 40, or 2 square roots of 10. This is 64 plus 400, so 464. So that's not one I know off the top of my head, but I know that 4 goes into that. Let's see, 1, 1, 6. 4 goes into that. Let's see, 2, 9, and then that's prime. So if we take the square root of 4 times 29, we get 2 times 2 times 29. Those are not like terms, so we can't combine those. If it asks for a decimal approximation, you could do that, but this is the exact value there. Now let's do a dot product. Let's do u dot v where u is the vector 3, -4, and v is the vector 2, -5. So the dot product also is referred to as the sum of the parallel products. These are both in the x direction, so those distances are parallel. These are both in the y direction, so those distances are parallel. So what do? We multiply the x from u times the x from v. We add that times and multiply the y from v times the y, or I'm sorry, the y from u and the y from v. So 6 plus 20, so 26 is the dot product. And notice that when we do this product, it's not a vector, it's just a scalar. All right? Another thing we're asked to do is, given a vector, find a unit vector in that same direction. So a unit vector is a vector who has a length of 1. If we take this vector and multiply it times a number, it's going in the same direction. It just gets bigger or smaller. So we want to change the distance to being 1. So we need to find out, well, how long is this to begin with? So the magnitude of u is the square root of 5 squared plus 12 squared. So the square root of 25 plus 144, which is the square root of 169, or 13. So that's how long this vector is 13. So we want a vector that's in that same direction, but is only 1 unit long. So we want 1/13 of that. If you have 13 and we take 1/13 of that, notice those cancel and give us 1. If we had a vector that's 4 units long, we would want 1 out of those 4 pieces. If we have a vector that's 10 units long, we would want 1 out of those 10 units. So if our vector u, that's the vector, if we want to be 1 unit long, we want 1/13 of that vector. So 1/13 of 5 and 1/13 of 12. So our unit vector would be 5/13, 12/13. So that would go the same direction. If we drew this vector and that vector, they would be pointed exactly the same way. This vector just has a length of 1. And let's check to make sure that does have a length of 1. So if we take the magnitude, it's the square root of the x component squared plus the y component squared. So if we square a fraction, we square the numerator and denominator. Numerator and denominator. We add those, we have the same denominator, and we add the numerators together, we get 169. And yes, that vector is 1 unit long. So this is what we're looking for. This is a vector in the same direction, but is only 1 unit. A couple problems ask us about I hat and j hat. I hat is just a unit vector. Anytime we see a hat, the previous problem we were looking for a unit vector u, the hat means it's a unit vector. So I hat is a unit vector that is horizontal. J hat is a unit vector that is vertical. So if we have the vector 2, 5, then we've gone 2 in the horizontal direction, so we've gone 1 unit twice. And if we've gone 5 in the vertical direction, then we've gone one vertical unit 5 times. And that vector is just the combination of the horizontal part and the vertical part, so as a sum. So that's just another way of writing component form. There are times in physics or different applications where we may have a function, a t, where it's described as an I hat and a j hat combination, and it may describe the motion of a particular particle. So at different t's, it can tell you how far to the right, how far up or down you are. Put another t in. At that time, how far over, how far up are you? So it's just another notation for dealing with vectors. Another question is, what direction is the vector -3, 7 pointing? So if we just roughly sketch, if we go -3, that's to the left, and 7, that's up. So vector v is pointed in that direction. So our angle is from the horizontal. So we want to know that direction. So 7 is the vertical part, -3 is the horizontal part. And it turns out the formula for this is tangent theta is the y part over the x part. So if we take tangent theta of 7 over -3, think about this being a right triangle. There's a relationship between this angle and that angle, but the vertical part over the horizontal. So if we take our calculator and do 7 over -3, and then we take inverse tangent, we get -66.8. But notice, if we're up and to the left, that's not in the direction of -66.8. -66.8 is this way, 66.8 degrees. So our reference angle is 66.8, but that is in the second quadrant. So we are 66.8 degrees from horizontal. So things we've been doing in the past is just applying it to vectors. So if we want to find theta, this horizontal direction here is 180. From 180, we're going backwards 66.8 degrees. So theta is 113.2 degrees. 180 minus 66.8. So that's the direction we're pointing. What if we're given two vectors and we're told vector u is in one direction, vector v is in one direction, and we need to know at what angle those two vectors interact with each other. In the previous section, we were told the length of two vectors and we were told the angle between them. But if we are given two vectors, we may need to know what that angle is between them, and that might not be told to us. So how are we going to do that? So let's suppose u is 2, 5, and v is, let's say, 3, -4. Then in order to get the angle between them, and we'll call that angle between u and v theta, the formula is cosine of angle theta is u dot v over the magnitude of u times the magnitude of v. So we need a couple of things. We need their dot products. So if we do u dot v, remember we multiply the x components, so 2 times 3. We multiply the y components, 5 times -4, and we add them together. So 2 times 3 plus 5 times -4. So that's 6 plus negative 20, which is negative 14. So that's their dot product. All right, to get the magnitude of u, that's the square root of 2 squared plus 5 squared, so the square root of 29. The magnitude of v is the square root of 3 squared plus negative 4 squared, which is the square root of 25, or 5. So cosine theta, oops, I thought I was changing colors. Cosine theta is negative 14, that's the dot product, over u, square root of 29, times magnitude of v, 5. So we can just get this as a decimal and then take inverse cosine. So cosine theta is about negative 14 over the result of the square root of 29 times 5. So that's negative 0.5199. So if we take inverse cosine, we get that to be about 121.3 degrees. Now, when it says the angle between the vectors, that is the angle between them if they were starting from the same location, if they were interacting at the same point. So let's just check that real quickly with a graph. Let's just start at the origin, and if we draw the vector 2, 5, and then if we draw the vector 3, negative 4, so from the same place, go 3, negative 4, then the angle we just found was this angle. Here's u, here's v. U is pointed that direction, v is pointed that direction. That's the angle between them.